Right, this isn't tidy at all, and there's no key. Well, there's one key. The main thing is it's working, so the screen's in. I'll go into more detail later, but basically I've polished the drum brake and ensured that it's central. I've 3D printed this about 6 times, changing it every time, so it's a tight fit now. And the secret to getting this to turn without lumpy points was to reverse it. So the problem we had before was that drum brakes in cars, they self-energize. In other words, you don't need much pressure pushing the pads onto the drums, because as the drum turns it kind of drags the pad with it. So what I've done is the opposite. I've actually set it up in the most inefficient way now, and so there's a spring here, tensioning cable, and most of the braking is done by this region of the pad, and if the wheel's slightly off center as it goes round, this will just take up the slack. So it's very, very smooth, much better. My shaft is precision ground, and I would have these laser cut ultimately, but I made this one by hand from a flat piece of steel, and I just TIG welded it on, to be honest. It's actually pretty quick, as long as you've got a jig to hold it. Quicker than putting a thread onto it and having 2 nuts, and it looks better too, arguably. I love this knob, I think it's great. Screen's working. I've got an Adafruit screen for you. I don't know if you've got one or whether you need one, because this board will be yours ultimately. Here's the socket for the wireless transmitter. I've changed my mind and I have included my little blue button because I just like them. So, setup here. We've got the chunky USB with the 90-degree bend on it. That looks really, really nice. It's really neat. Going into my iPad at the moment, and with one hand, with my elbow on it, I'll just try and crank. I've got all sorts of knobs, but I had these special ones from China. You'll notice they go to 11. I thought that was quite cool, but I have some more traditional ones as well. Going on to the circuit board, there it is. Got the Molex connectors all along the bottom. I might use 90-degree ones next time, possibly. Circuit board has one mistake on it. I've had to solder one extra wire on by hand, but that's not too bad, I suppose. If we open this up now, if I turn it over, I'll show you actually what's going on. So to assemble this, you slide the rod in with this flange already bolted to it. You drop this down through the top slot, and then using this extra hole that I made to get your screwdriver in, you do up these bolts which go into the plastic. This just makes it much easier than using the L-shaped Allen keys. And you know, I'm sorry to cut a hole in your design, but you could put a plug in there or a little plate over it. This looks great in the center. Yeah, I'm not sure what to do because it looks great in the center, but of course if you forget to put the potentiometer in before you put your rod in, then you can't get the potentiometer in and you have to take all this apart again. So maybe you might move it a little bit to one side, but it's a shame because I agree it does look good in the center. I carved away a little bit of material here in my many struggles with this mechanism. Actually, now it's full. Now I've got a working system. I didn't need to do that. So basically the band is reversed. The band now goes from here, your original mount, all the way around to there, and then the tensioning wire is at the top, comes down through a hole in the top deck to your tuning peg in its original position. And I've added a spring in the system as well. You can see here, I don't know if you can see here, this bracket could be about 2 millimeters less wide, because I want this up that way. So I could put some washers in here, but it's very fiddly. You could print that a couple of mil less wide. And then when I've struggled and struggled to get all this right, you'll notice I've got the bearing on this way. I haven't tightened the grub screws on this bearing. The reason the rod doesn't slide around is because of the 2 grub screws here. So you can undo those and you can move it in and out a little bit and lock it again if you find that your wheel is rubbing the wood or too far out and the band isn't round it. And then when you've got all that ready and done, you just push fit. This is just a push fit, a chopper wheel. I've got a 3D print here. It's held through the deck with 1 bolt there. It's got 2 little bolts holding it. So because it's held with 1 bolt, it means you can move it like that or that till you get it just right. You can see that's just right. So that all comes apart really fast. Now you're looking at this and you're thinking, the wheel is going up through the deck. Why can't I see it on the top? The reason you can't see it on the top, you see a cunning thing here, is because it's inside the key box. The top of the wheel is inside the key box, just slightly. So I've just modified your mounting point there. That's the, sorry, very fiddly. That is the Teensy LC that is reading the chopper wheel, converting it to an analog voltage. I know it's crude, and sending it to the pin that originally had the voltage from the gear motor. The advantage of that is I can use Basil Lally's amazing code without having to modify it, because it's a bit complicated. I'm sure it's very efficient, but it's a bit hard for me to understand. This is working. I tested it earlier. It works fine. Talking about tangents, right? Oh, we lost the other one already. Here we are. No, I've got 2 sizes of tangent. Here's the other one. Basically, the narrowest keys in the whole assembly are these here. There's 2 key stems there. So if you look, this tangent is less than half the width of there. So it will fit on that one. It'll also fit on that one. And you can see how it works. It acts as the backstop for the key. You can see it's flush. I've only got the 1 key. It's flush with the back, and there's about a 1 mil to 2 mil gap there before it touches the micro switch, and then it triggers it. Now I've gone for 4 mil standoff because I thought, well, if I have long standoffs, if there's any error in the location of the lateral error in the location of the PCB, it's going to jam against the key, whereas if it's pretty close to the back, there's probability of that is probably reduced. There's one other thing I'll need to discuss with you, and that is if you look at my Gurdy, my previous Gurdy, you'll see my keys don't stick out as far as they do on a DGurdy. See, like that. And the reason is when you press it, you'll hear the click as the micro switch triggers. If you go about another millimeter, the key hits the deck, it hits the wood. Same here. And it's to protect the micro switch from taking all the force. If someone's playing aggressively, hitting these really hard, you'll activate the switch, but then all that force then goes onto the micro switch. So what might be good is if you move the heads of your keys, all of them, back. Or if you didn't want to do that, make this space here, you see that edge there, bring it back to here, so that the switch gets triggered, and then you go another millimetre and it hits the deck. So you would fill this space in, or you would just move the ends of all the keys back a bit. And that protects the micro switch, I think, in the long run from heavy hits, as it were, from people who press very hard, because ultimately it would just hit the front. So I can send you dimensions for that. But yeah, this seems to work. You can just put the bolts straight down into the wood. That's great. What else? I think that's it for now. It needs tidying up. It's very messy, but the main thing is it does all work. Oh, one other thing, I'm not quite sure the best solution for this, but you know this tube, sorry, here, on the previous version it went through an end bulkhead, a middle one, then it hit the back one, which was solid. Whereas I know it's difficult for you to kind of do that on this design, but it's not held quite so well. So if you remember, I'll just show you that. Hang on. See here? See this one? It goes through the front, through a middle bulkhead, and then it hits a solid one. And then the 3D printed cap just holds everything in. But if you take the 3D printed cap off, the whole thing slides out the first time when you need to put a battery into it. Once there's a battery in it, you'll never need to remove it again. So not quite sure. Also, this hole, for some reason, it's a bit oversized there. I'm not sure why. That hole is correct. But you know, we could find ways around that, or if you want to just think about that, that's great. This little wedge shaped thing works very well because it places the pins upwards, so I can just unplug that if I need to adjust it or remove it, take this off, take the drum out. It all comes apart pretty well. So that's it really. The small modifications, other modifications I made is because the PCB is on a 4mm thick standoff, I had to widen this slot. You see the edge here? On this side I had to widen it by just 2 or 3 millimeters, so these PCB went down past it. And of course I also made a slot there for the top of the chopper wheel. I was struggling earlier today with all of this, and I actually had to cut this back. Of course now there's no need to. There's no reason why it couldn't be there as you probably originally had it. And I notice you've cut this out here. That doesn't need to be like that either. It could just as easily, it would work just fine like that. So you could almost use this as you'd had it originally planned. It just needs a bit of adapting for this arrangement here. So that's just a spring, off-the-shelf spring, bolt through there, and then I've tied the catgut or whatever you use to that with a cable tie for good measure. It goes down and then onto the roll tuner peg. So I just cut a slot there and then a hole straight through there, which is the neatest way to do it. So yeah, I've modified your woodwork slightly, but on the other hand, it does all work. It's really great actually. It fits on your lap a lot better. I really like the fact this is a little bit shallower. Just makes it more comfortable to play. So that's great. And I've formed a company. I have the domain DGurdy.com already. I'd actually forgotten I'd got it. And I'm in the middle of building a website. If you go to DGurdy.com, you'll see a half-built website that's just messy because I'm learning, but it's got a bit of text, it's got the wrong photographs, but I'll get there. It's more important for me to get this done today, to be honest.